On March 1, 1982, a Soviet spacecraft landed on the surface of Venus, survived 457 degrees Celsius measured at its landing site, endured 89 atmospheres of pressure, and transmitted data for 127 minutes. No machine before it lasted that long. No machine since has tried. Venus looks peaceful from a distance. Wrapped in white clouds, roughly the same size as Earth. But beneath those clouds, sits the most hostile surface in the inner solar system. The ground temperature hovers around 457 degrees Celsius, hot enough to melt lead. The atmospheric pressure at the surface is 89 times that of sea level on Earth. The air is not air. It is a dense blanket of carbon dioxide, laced with sulfuric acid clouds. Sunlight barely reaches the ground. What does get through, gives everything a dim orange glow. Nothing about Venus invites visitors. In the early 1960s, the Soviet space program needed a win. The Americans had their eyes locked on the moon. Mars was far away, and deeply uncertain. Venus was closer. At its nearest approach, Venus sits roughly 38 million kilometers from Earth. Closer than Mars ever gets. Soviet engineers believed they could reach it first. And they did. Venera 1 launched in February 1961, becoming the first spacecraft ever aimed at another planet. But reaching Venus, and surviving Venus, were two entirely different problems. The Soviets chose Venus partly because of distance, partly because of timing, and partly because no one else was seriously trying. Over 2 decades, they would send more than a dozen missions. Some worked. Many did not. But they kept going. Venera 1 lost contact before it reached Venus. Venera 2 also failed during its flyby. Venera 3 crashed into the surface in 1966, and returned nothing. It was the first human object to reach another planet. But it sent back no data. The early missions kept dying in transit, or breaking apart during entry. The Soviets did not stop. Venera 4 entered the atmosphere in 1967, and transmitted readings as it descended. But it was crushed before reaching the ground. Venera 5 and 6 met the same fate. They had underestimated how extreme the pressure really was. Every failure taught them something. Venera 7 finally reached the surface in 1970, and transmitted a weak signal for 23 minutes. The data was faint and garbled, but it confirmed the lander survived touchdown. It was the first successful transmission from the surface of another planet. Venera 8 followed in 1972, and lasted 50 minutes. Then came the cameras. Venera 9 and 10 arrived in 1975, carrying imaging systems. Both returned pictures. But on both missions, one of the 2 camera lens caps failed to eject. Each lander carried 2 cameras, pointing in opposite directions, and on each one, a cap stayed stuck. Half the planned images were lost. The engineers redesigned the ejection mechanism. Venera 11 and 12 arrived in 1978. Both lens caps failed to release. On both landers, all 4 cameras were blind. 4 missions, 8 caps. 4 stuck. For Venera 13, Soviet engineers rebuilt nearly everything. The lander's pressure vessel was made from titanium, shaped like a sphere, to distribute the crushing force evenly across its shell. Inside, the electronics sat in a sealed compartment, pressurized to 1 Earth atmosphere. The walls were thick. The seals were tight. But pressure resistance alone was not enough. The heat would cook the instruments within minutes, unless they found a way to manage temperature. The solution was phase change cooling. The interior of the lander was lined with lithium nitrate trihydrate, a material that absorbs enormous amounts of heat as it melts from solid to liquid. It would not stop the heat forever. Nothing could. But it would buy time. Nothing in the design was meant to last. It only needed to last long enough. Keep the instruments alive long enough to complete the mission, collect the data, and transmit it before the Planet 1. Venera 13 entered the Venus atmosphere on March 1, 1982. The descent took roughly 62 minutes. During the fall, instruments measured temperature, pressure, and chemical composition at different altitudes. A parachute deployed high in the atmosphere to slow the craft initially. As the lander dropped deeper, the atmosphere grew so thick, the parachute was jettisoned. The dense air alone slowed the descent. Near the surface, the lander was falling through an atmosphere so heavy, it behaved almost like a liquid. Venera 13 touched down at Phoebe Regio, an elevated volcanic plain. The landing was hard but controlled. The shock absorber compressed on impact. Within seconds, systems powered on, and instruments began their work. The clock had started. The cameras were ready. But first, the lens caps had to go. After the repeated failures of Venera 9, 10, 11, and 12, the engineers had completely redesigned the ejection system. Pyrotechnic charges fired. One lens cap released. The other did not. For the first time, at least one camera on a Venus lander had a clear view of the surface. What they recorded was unlike anything seen before. The first color panoramic photographs from the surface of another planet. The images showed flat slabs of rock, fractured and layered, sitting on fine-grained soil. The color was a deep, burnt orange, filtered through the thick atmosphere overhead. The horizon was visible but close, slightly curved by the wide-angle lens. Scattered on the ground near the lander, one of the ejected lens caps sat clearly in the frame. It became one of the most recognizable objects in space exploration history. A small metal disc, resting on the surface of Venus. Proof that this time, the caps worked. The lander carried more than cameras. A spring-loaded arm extended from the body of the spacecraft and pressed into the surface. It collected a small sample of soil and retracted it into a sealed analysis chamber inside the lander. This was the first time soil from another planet had been drilled and analyzed on location. The instrument identified the sample as a weakly differentiated melanocratic alkaline gabbroid, a volcanic rock unlike most basalts on Earth. Meanwhile, a microphone on the lander recorded sound. The audio captured the noise of the Venerian wind, low, steady, and faint. The wind speed at the surface was measured at roughly 0.3 to 0.6 meters per second. Barely a breeze. But in an atmosphere that dense, even gentle wind carried real force. Inside the lander, the temperature was climbing. The lithium nitrate was absorbing heat, melting steadily, doing its job. But the planet was relentless. Minute by minute, the internal temperature crept upward. The instruments kept transmitting. The data flowed upward to the orbiter circling above, which relayed it back to Earth. The design survival time was 32 minutes. Venera 13 passed that mark, and kept going. 60 minutes. 90 minutes. Still transmitting. At 127 minutes, the signal stopped. The heat had finally won. The lander went silent. It had lasted nearly 4 times longer than expected. In those 127 minutes, Venera 13 returned 8 color panoramic images, completed the first chemical analysis of Venus surface soil, recorded the first audio from another planet, and measured atmospheric conditions from cloud tops to ground level. The data confirmed that the surface was volcanic, relatively young, and constantly reshaped by extreme conditions. The orbiter above continued its own mission, mapping from a safe distance. The data did not travel directly from the surface to Earth. Venera 13 spoke upward to a flyby spacecraft passing overhead, which then relayed the signal across tens of millions of kilometers. As the relay geometry changed, the signal grew noisier. This was not an instant failure. The lander was still operating, while the link slowly degraded. Inside the pressure vessel, the phase change material was nearly exhausted. The temperature continued to rise. The electronics were approaching their limits. Engineers on Earth watched the stream of numbers thin out, knowing there was nothing left to adjust. When the transmission finally stopped at 127 minutes, it was not dramatic. It simply ended. But the lander was done. It sits on the surface of Venus today, somewhere on Phoebe Regio, slowly being consumed by the atmosphere. The titanium has likely held its shape. The instruments inside are long dead. No photograph has ever been taken of it from orbit. It simply remains there, a silent metal sphere, on a planet that destroys everything it touches. 3 reasons explain why no nation has returned to the surface of Venus since the Venera program ended. First, the engineering cost is enormous. Building hardware that can operate at 457 degrees Celsius measured at the landing site and 89 atmospheres requires specialized materials and testing that consume years of development time. Second, modern electronics are more sensitive to heat than the simpler analog systems the Soviets used. Today's processors fail faster under extreme temperatures. Third, the scientific priority shifted. Mars offered the possibility of water, past life, and eventual human exploration. Venus offered a confirmed death sentence. Mars offered long missions and clear goals. Venus offered only hours. Venera 13 was not built to last. It was built to work fast. And for 127 minutes, on the surface of a planet that crushes and melts nearly everything, it did exactly that. It sent back color images, sound, and soil data, from a place no human will likely visit in our lifetimes. The lens caps finally opened. The drill worked. The signal held. And then it was over. One question for you. If a new Venus surface lander launched tomorrow with modern technology, how many minutes do you think it could survive before the planet killed it? Drop your number in the comments.